Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, happy downhill day to you. Over the top, go on the way down after today. Short week, all good. And can you tell I am still bubbling over with excitement? Do you see the bubbling occurring as we speak? Why? Well, for first reasons, last night, when I was out looking at Jupiter, so I was using my binos, and I saw either 2 Galilean moons or 3. I think I saw a third one. So I think I saw 3 out of 4 of the big moons of Jupiter. And then Saturn, now you can see Saturn is not far behind Jupiter. And you know that over the next 3 months, December 21st is the finale, where Saturn and Jupiter are going to close, and they're going to be so close, astronomers are calling it a great conjunction. Not just a conjunction where they're close to each other, but really close. A great conjunction. Closest they've been to each other since 1623. That's a big deal. So I'm really excited about it. So keep an eye on Jupiter and Saturn in the evening sky high in the south, and just watch them get closer and closer. Now at the door, you should have gotten a scientific method handout, which we will go over in a little while. Oh, and I wanted to tell you, this morning on my walk, I saw a second pair of planets. Remember the evening, Jupiter, Saturn? In the morning now, 5:30-ish a.m., I told you about it already if you want to go for it. Ask your parents' permission. And then the very bright Venus high in the east, and the orangish red iron oxide rust, Mars up over the top and to the west a bit. So have a look at both of them. So, and I have a special on just this week. It goes in the computer next Saturday. So here it is. If you haven't seen Jupiter and Saturn, I saw Jupiter and Saturn, pointed out to a parent's signature, look for the Galilean moons if you can, and then in the morning, for getting up early, 5:30-ish a.m., with parents' permission. So some of them might be up already. Look for Venus, so bright because of the thick atmosphere, high albedo, high reflectivity, and then Mars has had water, it's got iron in the soil, it's had oxygen, therefore it's got rusty soil, an orangish red soil. Anyway, 10 points each. This week only, a special is on Science Special. Take advantage of it. Okay, your do nows, as usual. You've got your LP out, your lesson planner. You're putting your homework in your LP. And your homework is your triple R-ing already. Well, remember now, it's Wednesday. So you're reviewing already for Friday's test. I'll say more about it shortly. So you've got your journal out. You've got your verse sheet out. There it is. So you've got your Bible verse sheet out. And I'll mention it in just a little bit. And then, let's see, you've got your lake level analysis paper out. Mr. Gilbert will be correcting that with you in a little bit. So you've got a red pen out. You're correcting it. And then I've already mentioned your scientific method paper, which you got at the door. Okay, so you'll want to review this really well. Now I'm telling you right now, some of you have figured out how I operate. Mr. C, do you on a regular basis tell us at least the general information that's going to be on Friday's quiz or test? Yes, I do. So, in a way, is there any excuse for you to go, oh, I didn't really know what was on the test? Yes, you did. If you watched the video, you sure did, because I went over it, and I put it up on RenWeb for Thursday evening, probably Wednesday evening, Wednesday homework as well. The categories that are on the test are on RenWeb, so you've got 2 ways to know that. So now, I'm telling you right now, the test is going to be 30 to 35 points. Let's say it's 30. Okay. You are going to have to write John 1, 1 to 3 again. Yeah. Why? I want you to remember it. Long-term memory. So I want it long-term memory. That's 3 points this week. Ooh, 3 out of 30. 10%? So and there's some of you that, most of you have been getting partial credit. Now I want you to know all of it. So all 3 verses. In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things came into being by Him, and without Him, nothing came into being that has come into being. 3 points. Now, here's the deal, Lucille. Not many, but a few of you have been blowing the verses off. Just not doing them at all, not learning them. Here's what's going to happen. If you blow them off one more test, then I'm going to make note, and you get to be an advisory person who comes in and works on John 1, 1 to 3 until you got it down pat. So study it on your own. Get it on the test. I want you to know it. You cannot blow it off. So anyway, that's 10%. So if you blow it off, you're already at 90%. And then if you miss anything beyond that, you're in the B category already. And that's happened to a few of you. So get with it. Learn those verses. Are not all that hard. The meanings of the 2 more points. So already we're at 5 out of 30. So the meanings of John 1, 1 through 3, 2 of them. Then Genesis 1:26, then God said, let us make man in our image, 1 point. And then 4 ways that you are like God. He made you in His image. You've got to have the critical one first. He made you in His image or in His likeness. And each one is half a point, so that's 2 more points. So, and then I'm telling you right now, I'm going to ask you a couple of things about SSRs. It's going to be worth a point. How do you respond to an SSR? Thank you, Lord. What are you supposed to do with SSRs? It says it in 1 Timothy 6. Enjoy them. Enjoy them, and maybe thank God again. So, and that'll supersize it even as you are appreciative, showing gratitude. Then I've got 1 question about human body system organs. Are you going to ask us all the organs like in the digestive system? No. Respiratory system? No. A general question about the organs. 1 point. And then I'm going to ask you a question about the speeds of the Earth and the Sun and the Milky Way galaxy that we're a part of. So, are you going to have us memorize the speeds? Read my lips. No. Just a general question about the speeds. The Earth right now is rotating at 1,000 miles an hour. The Earth right now, in its revolution around the Sun, 67,000 miles an hour. You might want to stick these in your journal for interest's sake. Share them with, a high schooler. Hey, did you know how fast the Earth is rotating? And they probably don't. So 1,000 miles an hour, or, share it with a neighbor friend, put them to sleep. Did you know how fast the Earth is revolving around the sun? 67,000 miles an hour. Well, maybe not, pass that on. Maybe not. So, and obviously the Earth is going around the sun. So do you know how fast the sun is moving through the Milky Way galaxy right now? 450,000 miles an hour. Wow. I think I shared that with you before. 450,000 miles an hour. Wow. And then, one more question. What haven't I asked yet? Hey, Mr. C, how fast do we think the Milky Way galaxy, and you're seeing a picture of it, a photo of it right now. Actually, it's Andromeda. We can't take a picture of the Milky Way galaxy because we are in it. But we can take a picture of a similar galaxy, a spiral galaxy like we think we are. It's called Andromeda. So, anyway, the Milky Way galaxy is traveling 1.3 million miles an hour through the universe. So in a way, that's how fast we're going. You get that? So someone says, hey, how fast is the Earth going? Well, that depends. Are you talking rotation? Revolution? The sun that the Earth is hitchhiking on, gravitationally speaking? Or the Milky Way galaxy that the sun is a part of and moving with it? So anyway, I'm going to ask you one general question on the speeds, all those speeds. So then there is Stellarium, and there it is, Stellarium. And remember, I'm all excited about Stellarium because Stellarium shows you, first of all, where you're located, and it comes up on my computer, Mesa, Arizona. So, and then there's a little feature down in the lower right-hand corner where you can change from daylight to darkness, or you can go right before the sun comes up, which you'll want to do, and find Venus and Mars, and then you'll want to switch over on it by moving the time bar over to the evening, say 7 p.m.-ish, and then you can see high in the south Jupiter and then Saturn following behind. Here's the story on Stellarium. If you spend a minimum of 10 minutes on Stellarium and you work out how to get the correct place where you're located, Paradise Valley or North Phoenix or wherever, Scottsdale, and then the time on the little time bar, and you find the planets, the planet pairs that are up there, and maybe some of the others that are there as well, and you change the time so you get kind of a different look on Stellarium about where everything is. If you're able to do that, and you hand in a little sheet of paper into the box, I spent a minimum of 10 minutes on Stellarium doing what you asked. 10 points. Wow. Now, I can't give too many more 10-pointers or it'll skew your grade. But anyway, these are all on the table for you. So enjoy, have a look, looking at them with your eyeballs if you can, or then go on Stellarium. I'm also going to ask you about the two kinds of germs on Friday. How many points? Oh, probably 4 to 6 on germs. So, for instance, viruses are very tiny, very tiny. Starts with V, and the medication that kills viruses, vaccines. Is there a vaccine yet for COVID, a virus? No. Hopefully soon. Pray that. Lord, please give us a viable, powerful vaccine in just the next month or two. We ask in Jesus' name. Amen. So, and then viruses, I'll probably ask you this. I've got down here VCR. See that right there? VCR. Viruses can't reproduce on their own. They have to use a living cell to reproduce and inject their DNA or RNA into it, kind of hijack the cell. So anyway, and then what does COVID do? What does it attack? The lungs and breathing, as you know. So COVID is a virus. And then the bigger kind of germ, but not that much bigger, 4 to 10 times bigger, but it's still microscopic. Bacteria are bigger. And then AB, antibiotics kill bacteria. So that germ information is on the table. I'll ask you on Friday's test. Then I'm going to ask you a number of questions about the scientific method. So you're getting that sheet out in front of you, a highlighter, a pen. And then if we have time, I'm going to show you an Isaac Newton video. If not today, tomorrow. And I'll ask you a few, 2-3 points worth, 2 or 3 facts about Isaac Newton. So anyway, we'll see if we have time for that video. So you have your scientific method sheet out. It's this one, if you'll find this side. And if you'll get your highlighter out, first of all, in using the scientific method, they have to do with doing an experiment. So the very first step is you've got a problem. You've got an experiment that you want to test and get an answer to or a conclusion. You see number 6 is conclusion, and it's an answer that you derive from your data. So highlight problem, what we want to find out, and I'm going to propose a couple of problems. Here's the first one. And Isaac Newton supposedly tried out this experiment. Now, if I was in the classroom, I'd climb up on a table and you'd all go, oh, Mr. C doesn't fall on his head. But I'm not obviously climbing up on the classroom table because here I am. So let me explain the experiment that supposedly Isaac Newton tried. It's supposed to be on the Leaning Tower in Pisa, Italy. You've heard of it, most likely. Did he really do it there? We don't know. Did he really do this experiment? Maybe. But he came up with the answer anyway on his own, mathematically, because he was so brainy, so smart. So one of the smartest, most amazing scientists who ever lived. So here was his experiment, the problem, what you want to find out. If you had 2 different objects that are different masses, that means they've got more atoms. This one has a whole lot more atoms than this one. It has greater, we call it mass in science, just more atoms. Well, because it's got more mass, it's got more, I can't hear you. Oh, that's right, I couldn't hear you anyway. So, weight. So more mass, more weight. This object you can see is basically hollow. It's a cat toy. It's Scratch's toy, about the same size. Okay, and here's what he did. He dropped these 2 objects from the Tower of Pisa. They were different masses. One was a lot more mass, a lot more weight, and he dropped them at the same time to see what would happen. So make a hypothesis, a scientific guess, about what you think would happen. What do you think will happen This weighs, I'm just guessing, at least 10 times more than this, because it's got at least 10 times more mass, maybe 20 times more mass. So you've highlighted on here the problem, what you want to find out. Now, if you will highlight hypothesis, it's your scientific guess, but it's not a true guess. It's just where you really think about it. And you go, what do you think will happen? They've got very different masses. You're going to drop them at the same time from the same height. Will one fall faster than the other? Will they fall at the same speed? Will it be very different? What do you think? This is what Newton thought about and wanted to find out. So the problem, what you want to find out, hypothesis, your scientific guess. Okay? Then, in an experiment like this, you control almost all of the differences or variables. So, do you see on number 3 it says controlling the variables? Highlight difference. You see in parenthesis, keeping the differences the same. That's what control means. Above control, write same. Above control, write same. And above variable, write difference. What root word do you hear in variable? Vary means to be different, right? So difference, a variable. To be fair, you've got, in an experiment like this, you've got to control all the variables, except for one. Now, the one variable that's not controlled is the mass, right? And therefore the weight. I'm pretending that everything else is the same. They're falling through the same air. They're dropped at the same time from the same height. And they're released in the same way. Now, to be fair, you'd want to have some kind of device that would release both objects at exactly the same time, the same fraction of a second. Now, I'm doing it by hand, so it's sort of controlled, sort of kept the same, but not exactly. And Mr. C, it's not quite the same diameter. I know, I'm pretending it is. Okay? So, ideally it would need to be the same diameter, distance through the center from to side. Okay? So, those are the control variables. So, I'd like you to write down a few of the control variables now, please. So, same this, same that. So, same shape for the objects, they're spheres, drop from the same height. So you're writing that down where it says same right there. Same time, same atmosphere. Now, some of you who are thoughtful have already figured out to really control this variable, we need a vacuum. What do you mean a vacuum? We need no gas, no air, no atmosphere. It needs to fall through a vacuum. Otherwise, a very light object might be held up as the air molecules push against it. It might be slowed down and therefore change its speed in relationship to the greater mass object. Does that make sense? So I admit that variable should be the same. So let's put, it's an imaginary experiment, an experiment in the mind, but I'll actually drop them in a minute. So I'd like you to put same vacuum in those same ones. And they're traveling the same distance. So same time, same shape, same vacuum. and then I think I mentioned dropped at the same time. I think we had about 5. And then where it says one variable not controlled, that's the mass, different mass. So that would be number 4. So if you'll write there in number 4, different masses. And then number 5 is the data step, where you do the experiment and write down what happens. And you kind of do it like in a diary. Scientists would probably have a website where they'd be logging in data and just putting it online now, but at one time they might have used charts or some kind of paperwork where they would have listed the data. So to kind of help you out, the data is kind of like a diary. Draw a line from data in number 5 over to diary. Draw a line over to it. And then the example we're using, if you'll cross out Earth's temperatures, and in this case, actually I've got this side right here. You don't need to cross that out. Yep. So in number 5, we'll, and then when you gather your data, you should do it many, many times. So where it says data, put many times. So test it many times. We'll only do it like 3 because of time's sake. Okay. So you write down what happens. That's a data or diary. All right, here we go. All right, I'm going to try to drop them at the same time. And you'll have to trust me on my reporting. All right, 3, 2, 1. Okay, what happened? It looked like they hit at the same time. All right, second trial. 3, 2, 1. I didn't watch that time, so I'll watch this time. I want to make sure I get them the same height. 3, 2, 1. Looked like they hit at the same time. Third trial now. So you could put fell at the same speed or same rate according to this simple test. 3, 2, 1. Looked like they hit at the same time. Now, we'd want to drop them from a way higher height to do this well. So, like I say, I used to stand up on the tables and do it. Now, what did Isaac Newton find? He found that objects of different masses still fall at the same speed in a vacuum. So, if you will put in the conclusion, could you please draw an arrow from data down to conclusion? So from data, just draw an arrow down to the conclusion. You get your conclusion or your answer or possible answers from the data that you got as you did the experiment, as you actually did it. So the data reveals the conclusion. Okay? So those are the 6 steps of the scientific method. If you will review those, this evening, that would be great. And then I wanted to show you one other. Let me show you these. Now you'll have to test me on, or trust me on this. I have 2 pairs of binoculars. These are 8 power, 8 magnification, and these are 10s. Well, last night when I was looking at Jupiter, I looked at Jupiter a number of times using the 8 buys, the 8 power, And I had heard that 8 power, when you're just using them by hand, are a little bit easier to use and don't have as much shake as these are 10 power. They magnify 10 times. So 8 magnification, 10 magnification. And I looked carefully with both. So I kind of did a little experiment. Problem. So of the 2 different magnification binoculars, did one seem to be easier to use and have less shake? I had a hypothesis. I had heard that perhaps the 8 magnification would not shake as much, or it wouldn't appear to shake, and would be easier to see. In this case, Galilean moons that I was looking for. The variables controlled. The binoculars are identical, really, except for the magnification. And I did them in the same way. I tried to hold them steady in the same way with both of them, so those were control variables. They were made by the same company, another control variable. And then the one variable not controlled, different magnification. You don't have to write this down. I'm just telling you another scientific method experiment. And then I gathered the data, and I have a preliminary conclusion. I was testing this hypothesis. The 8 magnification seemed to have less shake. It seemed to be true. It seemed to be true. Now I'd have to gather a lot more data to get a more solid conclusion. Now your assignment tonight is review the 6 steps of the scientific method. Think through the dropping the 2 different mass objects. Think that through. Think those steps through. I'm going to ask you those 6 steps and then another question or 2 about the scientific method on Friday. So study it already. You already know what to study for the test. That's basically it. What teacher gives you, what's on the test, like 2 days ahead or 3 days ahead? So should you do well? Absolutely. And then tomorrow, Thursday, I'll give you a bit more detail, but you don't need too much more detail. Study those verses. If you didn't get John 1, 1-3, really go after it. Okay? So, anywho, I wanted to just remind you why I'm wearing my Blues hat, my rugby hat. I'll wear it all week because grandson Brayton plays in his grand final match 4 days from now. So it's actually Wednesday in Australia, so 3 days away for him. He's extremely excited. So anyway, I hope that's helpful. Review. I'm going to turn it over to Mr. Gilbert. He's going to give you answers to this second lake level experiment and then collect it. Be honest as you grade it. Just red pens out. No other pens or pencils. Mr. Gilbert, thank you. Take it away.